All right, so we want to talk about the transformations that we've done. We've done reflections, rotations, translations, and dilations, the ones we did this year. What is the composition of transformations? It is two or more transformations done on one figure. So it's doing back-to-back transformations. What are similar figures? For this one, we want to talk about figures having the same shape, but different size. So are all circles similar? Well, they're all the same shape, and they can have different size, so yes. Really, because we can do a transformation to get one to the other, and that's what we're going to look at. So here, if it is true that any two circles are similar, can one circle be mapped onto the other? Yes. Yes. If we and translate one circle to map onto another circle. And that's what we're going to have to do. So what transformations are being performed? Well, like we said, a dilation and a translation. Translation is 5, and a dilation is a growing or shrinking. So we move this circle over to here. So first, I guess we looked at a translation. We moved it here, and then make it to grow to the big one, we did a dilation. And you can do either or. If O prime is the image of circle O, then identify the location of O prime, we'll look at P. So the centers have to match up. That's what's important. The centers match up. What is the scale factor between the two circles? Remember, scale factor is image over pre-image. And since the only measurements we're talking about in a circle, we use radius. So our image is this bigger circle, radius S, and this pre-image is the smaller circle with radius R. So it is S over R. Two circles have to share the same center. The radius of one circle is 12, and the radius of the other circle is 8. Describe how the smaller circle is dilated to generate the large circle. By a scale factor of 12 over 8 is 3 over 2, or 1.5. You can put it as a decimal or a fraction. Doesn't matter. If we see the fraction, we'll see other relationships. Compare the ratios of the circumference of the two circles. Remember, the circumference is 2 pi r, or pi d. So the small circle, it is 16 pi. We want exact answers, so 16 pi units. The big circle is 12 is our radius, so multiply that by 2, we get 24 pi units. The ratios, we're going to put the bigger circle over the smaller to be consistent with letter A, and that reduces down to 3 over 2, or 2.5. The two areas of the circles. Remember, the area is pi r squared. Again, we want exact answers so that we can make sure that rounding is not going to be an issue. So our small circle has an area of 64 pi inches squared, 8 squared, and big circle is 12 squared, 144 pi units squared. So big, small again. Reduce that, it's 9 over 4 over 2.25. Compare the ratios we found in B to C. Now, if we look at this, scale factor equals the ratio of the circumference. But at the same area, because areas are squared, the scale factor squared is the ratio of the areas. 3 squared is 9, 2 squared is 4, so 9 over 4. And there we go. Circle S is located at 0, 0, if it has a radius of 4 units. Circle T is located at 2, 5, it has a radius of 10 units. Describe the sequence of transformations that prove that circle S is similar to circle T. Dilation, then a translation, or translation, then a dilation, doesn't matter. Let's do dilation first by scale factor of, and it's small to big, so we do the big circle first. We use the radius, the radii, so 5 over 2, 0.5. And translation, well, it went from 0, 0 to 2, 5, so x plus 2, y plus 5. So when we're talking about the dilation, we use radii. We're talking about the translation, we talk about the center. We have one just like this on our test. So make sure you know how to do that. Alright, now we're going to be looking at these 3 concentric circles, which mean they share the same center. And we're going to find the radius, the arc length, and then the ratio. Again, important stuff. Angles are all 60. Radius of circle 1 is 1, circle 2 is 2, and 3. Arc length, remember, arc length, so the measure of the arc over 360 times our circumference by r. So if we calculate that out, the arc length of number 1 is 5 over 3. If we keep it as exact answer. If we look at the second one, it's 2 pi over 3. And then here it's just pi, or 3 pi over 3. Again, just using this formula. When we divide it, arc length divided by radius, pi over 3. Pi over 3 divided by 1 is pi over 3. 2 pi over 3 divided by 2 is pi over 3. 2's cancel out. And pi over 3 is just pi over 3. So they're all the same. What pattern do you notice in the table? Well, that the arc length divided by the radius is the same. And what that is, again, hint, hint for the test, arc length divided by the radius is the measure of the central angle in radians. What we're going to talk about in a second. Another way to measure angles, so they can be in degrees or radians. Radian measure. So a circle in degrees is 0 to 360, while in radians 0 to pi. So to convert it, very simple, straightforward formula. To convert degrees to radians, multiply by 180. Oops. No. Pi over 180. To convert radians to degrees, multiply by 180 over pi. So same thing, but upside down. So if we look at the examples here, 23 and pi over 180, and we want exact answers. We keep pi in the answer, and we keep it as a fraction. So 20 goes into 20 once, it goes into 180 10 times, pi over 9. B, same idea, 7 times pi over 180. 90 goes into 273 times, it goes into 182 times. It's pi over 2. So notice that our radians have pi in the answer. When we look at our radian answer, which is degrees, they're already fractions. We multiply by 180 over pi. The pi cancel out, and that's what we want. The denominators also cancel out. 3 goes into 2 once, it goes into 180 60 times. So 2 times 60 is 30 degrees. Letter D, pi over 9 times 180 over pi. And the pi's cancel out. That 9 goes to 9 once, goes into 180. 20 times we get 20 degrees. Which is what we should get because in letter A we went the other direction. So that's what we're looking at. What's important from this lesson? We need to be able to convert. And we need to be able to remember that. And remember how to do this kind of translation.